Power steering is a mechanism designed to lessen the effort required by a driver to navigate the steering wheel of a motor vehicle. This is achieved by utilizing a power source that assists in steering. There are two main types of power steering systems: hydraulic and electric. In hydraulic systems, energy is added to the steering mechanism through hydraulic actuators, which reduces the physical exertion needed from the driver to turn the wheels, particularly when the vehicle is stationary or moving slowly. These systems feature a direct mechanical link between the steering wheel and the wheels being steered, allowing for manual steering in the event of power steering failure. On the other hand, electric power steering systems use electric motors to provide steering assistance instead of hydraulic components. The electric motor receives its power from the rest of the power steering system. In some cases, particularly in large off-road construction vehicles, power steering systems lack a direct mechanical connection to the steering linkage and rely entirely on electrical power. These systems, often referred to as drive-by-wire or steer-by-wire, draw a parallel to aviation's fly-by-wire concept. The term wire in this context signifies electrical cables transmitting power and data, rather than physical control cables. Notably, certain construction vehicles are equipped with a two-part frame joined by a sturdy hinge at the center, allowing the front and rear axles to adjust their alignment for steering purposes. Hydraulic cylinders in opposite directions facilitate the movement of the frame segments relative to each other to achieve steering. The first power steering system on a vehicle was reportedly installed in 1876 by an individual named Fitz, with limited information available about him. Following this milestone, a Columbia 5-ton truck integrated the next power steering system in 1903, utilizing a separate electric motor to aid the driver in steering the front wheels. Robert E. Twyford, hailing from Pittsburgh, Pennsylvania, included a mechanical power steering mechanism in his patent, U.S. Patent 646-477, granted on April 3, 1900, for the initial four-wheel drive system he developed. Francis W. Davis, an engineer working in the truck division of Pierce Arrow, delved into simplifying steering mechanisms and successfully demonstrated the first practical power steering system in 1926. After transitioning to General Motors, Davis enhanced the hydraulic-assisted power steering system, but the company determined it to be too costly for production. Subsequently, Davis partnered with Bendix, an automotive parts manufacturer. The demand for power assistance on heavy vehicles during World War II, especially for easier steering on armored cars and tank recovery vehicles for both the British and American armies, surged. This necessity further spurred the advancement of power steering technology. Chrysler Corporation marked a significant milestone by introducing the first commercially available passenger car power steering system in 1951 with the Chrysler Imperial under the brand name HydroGuide. Drawing from Davis's expired patents, this system laid the foundation for future developments in power steering. General Motors followed suit by incorporating a power steering system in the 1952 Cadillac, based on Davis's earlier work from nearly 2 decades prior. Innovator Charles F. Hammond from Detroit added to the progress by filing numerous patents for enhancing power steering systems with the Canadian Intellectual Property Office in 1958. Since the mid-1950s, American automakers have offered power steering technology as optional or standard features in vehicles, while it has become a common inclusion in modern vehicles worldwide. This widespread adoption can be attributed to trends favoring front-wheel drive, increased vehicle mass, cost efficiencies in assembly line production, and the use of wider tires, all contributing to heightened steering demands. Notably, heavier vehicles prevalent in certain regions would pose significant challenges in maneuvering at low speeds without power-assisted steering, whereas lighter vehicles may operate efficiently without such assistance. A study conducted in 1999 on the perceptual fidelity of steering force feedback highlighted the expectation among everyday drivers for an increase in feedback torque with escalating speeds. Early iterations of power steering systems that lacked this crucial feature were met with disapproval due to their inability to meet drivers' natural anticipations. Hydraulic power steering systems rely on hydraulic pressure generated by a gerotor or rotary vane pump, which is typically driven by the vehicle's engine. The pressure is used to amplify the force applied to the steering wheel, assisting in steering the vehicle's road wheels. A double-acting hydraulic cylinder exerts force on the steering gear to turn the wheels, with the steering wheel controlling the flow of fluid to the cylinder through valves. A torque sensor, such as a torsion bar, measures the torque on the steering wheel by detecting twist when the wheel is turned. The more torque applied, the more fluid is allowed through the valves to the cylinder, increasing the steering force. The hydraulic pumps are positively displacement type, delivering a flow rate directly proportional to the engine speed. To prevent overly quick steering at high engine speeds, excess pump output is redirected back to the reservoir by a restricting orifice and flow control valve. A pressure relief valve safeguards against excessive pressure buildup when the hydraulic cylinder reaches the end of its stroke. In case of steering booster failure, the steering functionality remains, though with increased difficulty. Loss of power steering can have a notable impact on vehicle handling, necessitating regular inspection of fluid levels and system maintenance as outlined in the vehicle manual. The hydraulic fluid, acting as the working medium for pressure transmission, is typically mineral oil resembling automatic transmission fluid. Additionally, some modern systems employ an electronic control valve to modulate hydraulic pressure based on the vehicle's speed, known as variable assist power steering. One such innovation in power steering systems is the Duravi variable assist power steering, pioneered by Citroën, which ensures a consistent steering force regardless of road speed. This system utilizes a high-pressure hydraulic system to steer the wheels, along with a separate hydraulic mechanism to provide artificial steering resistance that varies with road speed, contributing to enhanced driving experience and control. Introduced in the Citroën SM in 1970, this technology aimed to optimize steering precision and response under different driving conditions, known as VariPower in the UK and SpeedFeel in the US. Electro-hydraulic power steering systems, also known as EHPS or hybrid systems, utilize hydraulic assist technology with a pump driven by an electric motor instead of the engine. In the past, Ford experimented with alternative steering designs in the 1965 Mercury Park lanes, while Subaru introduced a unique adaptive electro-hydraulic system in the XT6 in 1988. Toyota's second-generation MR2 in 1990 avoided the need for hydraulic lines from the engine to the steering rack. Volkswagen's Golf MK3 Ecomatic in 1994 had an electric pump ensuring power steering even when the engine was off. Various brands like Ford, Volkswagen, Audi, and others have integrated electro-hydraulic systems in their vehicles. On the other hand, electric power steering, EPS, or motor-driven power steering, MDPS, replaces hydraulic systems with an electric motor for steering assistance. Sensors detect steering position and torque, allowing a computer module to apply assistive torque through the motor, enhancing steering based on driving conditions. Engineers can customize steering response to optimize ride, handling, and steering for each vehicle by adjusting steering gear response to suspension systems with variable rate and variable damping. These systems also enable the integration of driver assistance features like lane assist and wind drift correction. Electric systems offer fuel efficiency by eliminating belt-driven hydraulic pumps, simplifying manufacturing and maintenance with fewer components. Furthermore, electrically variable gear ratio systems allow for changes in steering gear ratios and assist levels. Honda's S2000 Type 5 and 2000 introduced the electric power variable gear ratio steering (VGS) system, while Toyota's VGRS on the Lexus LX 470 and Land Cruiser Cygnus in 2002, along with BMW's active steering system on the 5 Series in 2003, altered steering gear ratios and assist levels. These innovations provide a range of steering enhancements, including nonlinear types that adjust steering ratios based on steering angle rather than steering torque.